Hey folks, today in this video we are going to create an AI commit generator using large language models. So this is going to be a command line application that uses your offline large language models to generate commit messages based on the changes you have on your Git repository. So let's look at the demo. For the demo, I have this Git repository for my project called Ollama Manager. So currently I have two files that are on the staging environment. And if I see what changes I have made to these files, I can use the command git diff followed by -- cached. Then there are some changes related to the handle interaction function, some changes related to the list remote model tags, and then some changes related to get session and things like that. So let's use the tool that we are going to build, and the name of the tool is going to be AI commit. You can name it whatever you want. So we'll see this later in the video, how we can do that. So writing AI commit, I can just hit enter and it's going to generate the commit message based on the changes that we saw earlier. So it says that delete model interaction and update model fetching commands. So it's correct. And it also lists all the small details that we saw earlier, like improve the interaction handling, modify the list remote models and things of that sort. If I'm not happy with this commit, then I can press R and hit enter to regenerate the commit message again. And if I'm not happy again, then I can do this on and on and on until I'm happy with the commit message it generates. And once I'm happy with the commit message, I can just hit Y to commit it. And if I see git log and one line, I can see fix interactive delete command and enhance remote model tag retrieval. So this is the commit message that I chose. And if I want to see this more in detail, I can just do git log. It's going to show the title of our commit message and all the details on the body that we saw earlier. So let's get started with building this application. I'm in my code editor right now. I already have a project directory set up and I have also activated the virtual environment. For this tutorial, we are just going to need one dependency, and that is of Ollama. So I'm going to do pip install Ollama and this is going to install it. Now let's bring in some imports. First and foremost, we are going to create a function that we are going to use to execute commands on our command line. So for this, we are going to use the function run command. It is going to take a command as an argument. We are going to wrap all of this code into a try except block, and we are going to except for subprocess called process error. And whatever error has occurred while running the command, we will just print it and we'll exit the application with exit code 1, meaning it failed with an error. We are using subprocess.run followed by the command that we are going to execute. We are going to capture the output whenever that command is run, and we are going to capture it as a text. We are also going to raise an error if an error occurs while running the command, and we are going to set the timeout of 10 seconds, meaning if the program takes more than 10 seconds to run, then we are going to basically fail it. Once we have this function in place, I'm going to bring in all the commands that we are going to run for this application. So for this, I've created a commands dictionary. I have a couple of commands. So we have the first command, which is git repo. So this command is going to check whenever we are running the application if we are inside a Git repository or not. If we are not, then the program should stop immediately. We also have this clear screen command, and if the operating system is Windows, it's going to use CLS. On Mac OS and Linux, it's going to use the clear command to clear the screen. We'll see in a second why we need this. And we also want to commit using the commit message generated by our application using git commit. So we have that, and we are going to fetch all the stage changes on our repository using this command git diff -- cached. So now we have a function that can run commands and we have a list of commands. Let's create a function that will orchestrate all the application. So this is going to be called run. Here I'm going to wrap all of my commands inside of a try except block, and I'm looking for keyboard interrupt because this is going to be a command line application. So whenever a user presses Ctrl+C or whatever, it's just going to intercept that and it's going to say AI commit exited. The first command we are going to run inside of this is going to be is-get repo. So whenever we are running our application, the first thing we are going to check if this repo is a Git repo or not. Once we have all of this in place, we are going to run this file as a module. So I'm going to put if name equals to main, we are going to run the run function. So let's see our script in action. So I'm going to do python app.py, and it's going to say fatal not a Git repository or any of the parent directories Git. So as you've seen, we ran this command. It went through all of this. Since we have not initialized the Git repository in this project yet, it gave us this error. So as you can see, we print error followed by a line break and whatever error we get from the command line as e.std error. We have exactly that. So let's initialize the Git repository on this project. So I'm going to do git init. So once this is done, I'm going to run my application again. It should show no errors and no output. So the check has passed. Since we have validated that this is a Git repository, the next thing we need to do is that make sure we have staged changes. For that, we are going to bring in these changes. So we are going to run the command again, and this time we are going to run git stashed changes, which is going to be git diff followed by -- cast flag. Once we run this command, we are going to list all of the changes that we have on our staging environment. And if we do not see any stage changes, then we are going to show a message to the user saying no stash changes. And we are just going to stop the program. And if there is anything, we are just going to print it for now. So let's see this in action. I'm going to run python app.py again. It says no stash changes because I have not added anything to my staging environment yet. So let's do that now. If I do git status, I just have one file on my git repository. So I'm going to do git add dot, which is going to add app.py file to the staging environment. And now if I run my command, so python app.py, it's going to list out the diff of the stage changes I have. But yeah, let's move on. Now that we have checked if we have a valid Git repo and we have seen the changes on our staging environment, we need to pass these changes into the large language model. So based on that, we can generate a commit message that we can use on our system. So for that, first of all, let me add this system prompt, which basically says you are an expert AI commit message generator, which creates concise, informative commit messages. And I have some instruction for it. Your only task is to generate a well-structured commit message. And it has to be clear and descriptive. It has to focus solely on the technical changes, and it has to use present tense. There are also some guidelines that it needs to follow, like it needs to analyze the diff comprehensively, capture the essence of only the major changes, avoid generic or vague descriptions. And we just wanted to generate the commit message with no additional text or no explanation whatsoever. And after that, I've also given the LLM an example of what kind of output that I want. This is our system prompt. So after the system prompt, we are going to need a function that is going to interface with the large language model. And for this, we are going to use Ollama. So from the top, we are wrapping all of our code inside of the try except block. So on the first line, we have ollama.chat, and for the model, we are going to use llama 3.2 3 billion parameter model. On my testing, this model has performed really good. It also has a large context window. So it allows us to pass in a lot of changes at once, but in my experimentation, it only works with like small changes. For big changes, you might want to use a hosted model like ChatGPT from OpenAI and Anthropic or Google Gemini. So if you want to see a comprehensive application that supports both of these, then follow the link in the description. Having said that, the next argument is messages, where we are defining the role of system, where we are passing the system prompt. And next up, we have a role of a user, and we are passing the content or the message as here is the diff from the stage changes, and we are going to pass the stage changes, which will come as an argument to this function. And we are also going to stream all of the response that is generated from the large language model. And we are generating commit message followed by 50 dashes to separate this with the real commit message that the large language model generates. And if you have seen my previous videos, we have done this a couple of times. So the response from the large language model comes as a stream. So we are going to check each chunk of that stream. If the chunk has done inside of it, then that means that the large language model has finished creating the result. If the done is false, then it means that it's still creating the result. So inside of the chunk, there is a message key. Inside of the message key, there is a content key, which contains the actual text we want to display on the screen. Basically, whatever the output the large language model is generating, we want to display it on our terminal. So for that, I'm going to print the content. And end equals to empty string, because by default print uses a new line character for each text object it generates. To avoid this, we are using end as a blank string, and we are using the argument of plus equals to true, so that as we get the results from the large language model, we are immediately showing that result on the screen without buffering it anywhere else. So we are going to see in a moment like what it looks like if we don't have these arguments in place. And basically we have this commit message variable where we are going to append all the text that is being generated from the large language model. So for each text that it generates, we are just going to add it to the main text chunk, and we are going to return it. And if there is some exception, we are just going to say that error generating commit message, and we are going to exit the system. Now that we have this in place, I'm going to copy the name of this function. Let's come to our main run block. We are going to call this function with the staged changes that we have. So let's take this for a run. I'm going to run python app.py again. As you can see, generating commit message followed by 50 dashes. And yeah, it's generating the output with the exact format that we showed on the system prompt. So it is saying that add git repository validation and stashed change retrieval, added function to validate git repository. So basically, if I do git diff cast, you can see all of the changes that I have, which is basically everything that we have done till now. So it has summarized all of those changes neatly like this. So let's go back and let's change these things. So as I mentioned, the print by default uses a new line character if we do not mention this end argument. Let's delete this and let's see how our response is going to look like. So I'm going to run this script again. And as you can see, each character it generates comes to a new line, which is of no use to us. So I'm going to put end equals to empty string back here. And also if I do flush equals to false, which is the default value, and if I again generate this, then as you can see, it comes out very choppily. It is not smooth, one block at a time. So if I do flush equals to true again and run this, as you can see how smooth all of this is. So it's basically for that. Now that we have the ability to generate the commit message using large language models, we need to put into place the mechanism of regenerating the message and committing the message if we are happy, or just ignoring all of it if we are not. And for that, we are going to create a new function, which is going to be called as interaction loop. So interaction loop is going to again take the stage changes. So for this, we are using a while loop, which runs continuously until we break off of it. So on the first line, we are getting the commit message from the previous generate commit message function. So once we get the commit message, we are going to ask the user, do they want to proceed with the commit? So they have to use Y for yes. Let me delete that. So Y for yes, or they can write yes, N, or no, or R to regenerate all of this. So for this, I'm using the match syntax from Python. So if the user has pressed R or has typed regenerate, then what we are going to do is we are going to clear the screen. So from the commands, as you can see, clear screen. And for this, I have to run the subprocess.run explicitly instead of using the run command because it does not work otherwise. And I'm basically saying continue if the user has pressed R. So when we do continue, it's going to go through the loop again. So it's going to come here and it's going to generate the commit message. And it's again going to show this prompt for the user about what they want to do. And next we have the case where user presses Y or types yes. And for that, I'm going to print committing. And then I'm going to run the command with the command of commit. So if we see the command for commit, it's going to be git commit -m. As you can see, all of these commands are inside of a list. So for this, we are going to take the git commit -m command, and then we are going to add up that list with the commit message that was generated from our large language model that comes from here. That's why we need to wrap this commit message inside of a list. So to give a quick demo of what I'm doing here, I can do data equals to hello world, and I can do data plus. I can do exclamation sign. This will basically add hello world and an exclamation sign. So that's basically what we are doing in this command. And once we have ran the command, we are going to print the response from the command, which comes from git directly. And we are just going to print on the new line it has committed. So all of this /n are new line characters. I just want to create a space between all the text that's displayed on the screen. And the next is the case for n and no. It's just going to say that discarding AI commit message. In this case, we basically have to exit our program. It does break and we break out of the loop and there is nothing more to do here. And if the user presses something else, let's say they just pressed enter key or they type any of the P, Q, R, S, T, whatever key that is not mentioned here, then we are just going to say invalid action and we are going to break out of the loop and exit the program as well. So this is our neat interaction loop, which handles the user interaction so that they can either, regenerate the commit message, accept the commit message to commit it, or just reject the whole commit message and do it on their own. Once we have this in place, I'm going to take the interaction loop and I'm going to replace the generate commit message with the interaction loop. Now that we have this in place, our application is complete. So I can go here, do python app.py and run my application. So it's going to generate the commit message from our previously staged files. So as you can see, this is the new addition from our interaction loop. The application is asking, do you want to commit yes, no, or regenerate? So just for the fun of it, I'm going to regenerate. And you can do it as many times as you want until you are satisfied with the commit message it generates. And once you are happy with it, you can just type Y and press enter to commit it. And let's check the scenario of pressing N as well. So if I do git status, I have more changes on my app.py files. So if I do git diff, I'm going to see all the changes. So after my previous git add command, these were the changes that I've added to the application, which is the system prompt, generate commit message function, interaction loop. So I'm going to do git add for app.py, and then I'm going to run this program again. And this will give me commit messages based on my current changes on the staging environment. So if I don't like this message, I can just say no, and it will just say discarding AI commit message and the program exits. If I want to run it again and get a different prompt, I can do R. And as you can see, when I press R, it's going to clear all of the screen and it's going to start from the very top. So that is what the clear command is doing. So if I do R, it's going to clear everything up and then start from the top. So yeah, I'm just going to say N and no. So till now we are running our application as a Python script with python app.py. But earlier in the demo, we saw that there was a dedicated command line application that could be run from anywhere in the file system. So for that, we are going to look into Python packaging. So for the Python packaging, we are going to make some changes around the folder structure of our application. So I'm going to create a new folder called AI commit underscore. And then I'm going to move my app.py inside of AI commit, move it. And I'll also need init.py file inside of it. And this is our folder structure. And once this is done, I'm going to create a new file on the root of the project, and it's going to be called pyproject.toml. So to build a CLI application out of our script, we are going to need some build tools. So for this, we are going to install wheel, build, and setup tools. So these tools can be already in your system, but this is to make sure that you don't run into any errors when you are building the wheel or the distributed zip later on. So I'm going to install it just in case. It's already on my system. And next, I'm going to populate the pyproject.toml file. So for the build system, we are using setup tools. You can use other build tools like Hatchling, Poetry, and things of that sort. So I need setup tools that is greater than version 61. And for the build backend, I'm using setup tools.build meta. And whenever we are packaging our command line application, it needs to find all of the scripts or all of the modules inside of the application. So for that, we are going to include the AI commit directory. And these are just the metadata for the application. So the name of the application is going to be AI commit. The version is going to be 0.0.1. The description is going to be AI generated commit messages. And our dependencies is just Ollama with the version 0.3.3. So you can put a newer version of Ollama or whatever version you are running on your system in the future. So that's that. So the next important bit of this is project.scripts section, where we are defining how we can run our application. So AI commit, the variable that you see here, is going to be the command that will be accessible to our command line to run this application. So that is going to be the name of the application. If you want to do something else like AI committer or AI committer, whatever name you want for your CLI application, you can name it right here. For this tutorial, I'm just going to do AI commit. And then I'm going to tell it which function to run or where is the entry point of the application. So it says AI commit app run. So if we look into AI commit directory inside of app.py, I'm going to split it right here. We have the main function, which is run, which is being invoked inside of this. So this is how our final package will know how to run this application. Once that is done, I'm going to take out my command line and I'm going to write python -m build. And it's going to package everything into our dist directory. So if we look into dist directory, we have this wheel file and also the zip file. And to install this application globally, what I'm going to do is I'm going to deactivate my virtual environment. And I'm going to use Python 3.11 for this. And I'm going to use -m to install it as a module, and pip install. Inside of the dist directory, I have AI commit. My version is 0.0.1, so it's going to put that in here, and then all of the other metadata. And I'm going to install it on my machine. So as you can see, it says successfully installed AI commit version 0.0.1. And if I do AI commit now, it's going to run as it was running earlier. Exactly the same. So just to show that it runs anywhere on our file system, I'm going to go to a application called Ollama Manager. And from there, I'm going to run AI commit again. And there are no stage changes here. So if I do git status, that is correct. So that means this application is working correctly. So if you want to uninstall this application, you can simply do pip uninstall AI commit, and it's going to uninstall this application. If you want to update it, you can create a new package with version 0.0.2, and you can install it with Python 3.11 or whatever is your Python version of choice, followed by pip install, path to where our distribution exists. So that's it for this video. This was a quick rundown on how you can use large language models to create a command line application that generates automatic commit messages for you. Hope you enjoyed this video. If you like this video, give me a thumbs up. If you want to see more such contents in the future, subscribe to my channel, and I'll see you in the next one.